Have you ever stopped to wonder what's really going on under the hood of your Linux system? I mean, it might look all quiet and calm on your desktop, but behind the scenes, there is a whole secret world of programs running 24/7. Today, we're going to pull back the curtain on these silent workers and show you exactly how to take control.
So, picture this. Your operating system is like a massive, bustling city. The apps you open are like the cars driving down the street. But who's managing the traffic lights? Who's keeping the power grid online, making sure everything just works, even when you're not actively doing anything? Who's really in charge here? Well, that's exactly what we're about to find out. The answer lies with what I like to call the system's silent heroes. They're the backstage crew of your entire operating system. And in the world of Linux, we call them daemons. And no, don't worry, they're not some kind of evil spirit. They are incredibly important programs that work tirelessly in the background, handling everything from your network connection to scheduled tasks.
So what exactly is a daemon? And by the way, it's pronounced demon. Think of it as a process that runs completely on its own. You know your web browser, right? You open it, you use it, you close it. A daemon is kind of the exact opposite. It's designed to start up when your computer boots and just run constantly in the background, waiting for something to do. That little daemon managing your Wi-Fi, it's always on, just waiting for a network to appear so you can connect.
So what really makes a daemon a daemon? Well, it boils down to a few key things. They live in the background, obviously. They're totally independent of you logging in or out. They almost always start up when the system boots, and their whole job is to just sit there and listen for events, like a network request coming in or a timer going off. And here's a little pro tip for you. If you see a program name that ends in the letter D, like SSHD, HTTPD, or cronD, yeah, you're almost certainly looking at a daemon.
Okay, so we've got a handle on daemons. But here's where things can get a little fuzzy for a lot of people. You'll hear the words daemon and service thrown around, and folks often use them like they're the same thing. They are not. Let's unravel this right now.
Here is the simplest way to think about it. A daemon describes what a program does. It's a type of program defined by its behavior, running in the background. A service, on the other hand, is a management concept. It describes how the system handles a program. It's just a label the operating system uses for anything it knows how to start, stop, and keep an eye on.
And this one sentence right here just nails it. All daemons are services, but not all services are daemons. Think about it. The SSH daemon is a service because the system needs to manage it. But you could also have a service that just runs a backup script at midnight and then immediately quits. See? The system manages it, so it's a service, but it doesn't run continuously in the background, so it's not a daemon.
So if daemons and other programs are the workers, who's the city manager? Well, meet the init system. It is the absolute unsung hero of your Linux machine. It is the very first program that starts when you turn on your computer. It's process ID 1, and literally every other process is a child of it. It's the central nervous system of your entire OS.
Now, for decades, Linux used an old, reliable init system called SysVinit. And it worked, but man, it was slow. It started services one by one by one, in a very strict order, like a long line of dominoes. But today, pretty much every modern Linux system runs on systemd, which is a total game changer. It can start tons of services all at once, in parallel, which makes your boot times way, way faster.
And this chart really shows you why systemd took over. It's not just faster, it's way smarter and more reliable. The old system was kind of fire and forget. It would start a service and just hope for the best. Systemd, on the other hand, actively monitors every single service it manages. If your web server crashes, systemd sees it and can automatically restart it for you. It's a huge step up.
All right, so since we're living in a systemd world, we need to use the systemd tools, right? You can forget all those old commands you might see in outdated tutorials online. On any modern system, there is one command to rule them all, and you absolutely need to know it: systemctl.
I absolutely love this analogy because it is just so perfect. Using that old service command today is a total illusion. It might look like it's working, but behind the scenes, all it's doing is translating your old command into the real, modern systemctl command. It's just a wrapper. To truly be in control of your system, you have to talk to it directly with systemctl.
To see this client-server idea in action, let's look at a perfect real-world example: Docker. Now, Docker is all about running applications in these little isolated boxes called containers. And the magic behind it all is a powerful daemon called Dockerd. That's the engine.
So here's what actually happens. You go to your terminal and you type docker run. But here's the secret. That docker command you just typed, it does very little. It's just a remote control. It takes your request, bundles it up, and sends it over to the real engine, that Docker daemon running in the background. The daemon does all the heavy lifting, pulling the image, creating the container, and then just streams the results back to your terminal. The command you typed was just a messenger.
Okay, let's talk about the single most common mistake that trips up almost everyone when they're starting out with Linux services. It's the confusion between a service's current state and its future boot time state. You have to understand that these two states are completely 100% separate. Using start and stop controls what's happening right now. This is temporary. Using enable and disable controls what will happen the next time you reboot. This is permanent. This means you can have a service running right this second that won't start on reboot, and you can have a service that's stopped right now but is all set to launch automatically next time. They are two totally independent settings.
But of course, there's a pro tip to make life way easier. If you use the -now flag, you're telling systemctl to do both things in one shot. It will enable the service to start on all future reboots, and it will start it immediately, in your current session. It's incredibly efficient. And here it is, your essential cheat sheet. Start, stop, enable, disable, and probably the most important one of all when you're troubleshooting, status. Seriously, if you just master these 5 commands, you have mastered the fundamentals of modern service management on Linux. Okay, let's zoom in on that last one, because systemctl status is going to be your absolute best friend whenever something goes wrong. It gives you a complete, up-to-the-second snapshot of everything the system knows about a particular service. When you run it, there are a few key lines to look at. The loaded line tells you if it's set up to start at boot. Active tells you what it's doing right now. Is it running, is it stopped, or did it fail? And that little log snippet at the very bottom, that is gold. It is often your first and most valuable clue for figuring out why a service isn't working.
But, sometimes that little snippet isn't enough. When you need to do a real deep dive, the professional's tool is journalctl. With this command, you can see every single log message that a service has ever written, which is absolutely crucial for tracking down those really tricky, complex problems.
So there you have it. The secret world of background processes isn't so secret anymore, right? You now have the keys to the kingdom. You can see what's running, you can control what starts up, and you can troubleshoot any service like a pro. So my question to you is, now that you have the keys, which service are you going to go investigate first?